Hello everyone, welcome to my channel. I am Ritika and today we are going to solve the LeetCode daily problem, determine whether matrix can be obtained by rotation. So let's quickly understand what the problem state. Given two n cross n binary matrices, mat and target. Return true if it is possible to make mat equal to target by rotating mat in 90-degree increments, or false otherwise. So basically we are given two n cross n binary matrix, one is mat and another one is target. Now we can perform one operation on mat, that is we can rotate mat in 90-degree increments. If after any number of times of 90-degree rotation mat is equal to target, then we will return true, otherwise return false. For example, we have mat equal to 0 1 1 0 and target equal to 1 0 0 1. If we perform 90-degree rotation on the matrix only once, then it will look like 1001. That is basically our target. So we will simply return true. Similarly, we have another example, mat equal to 0 1 1 1 and target equal to 1001. See, we can perform at most 4 times 90-degree rotation on mat, because after performing 4 times 90-degree rotation, it becomes at its original position. So after performing 4 times, we can't able to find mat equal to target. That means we have to return false. Now coming to the constraint, we have n, that is mat length, target length, n equal to mat I length and target I length. N lies in between 1 to 10. That means n is not very large, and mat ij and target ij are either 0 or 1 because it is a binary matrix. Now in example 2, we have already seen that the number of 90-degree rotation we can perform at most 4 times. But how can we find or implement the 90-degree rotation on a matrix in our code? Let's see how we can do that. See, if we have an example, matrix looks like 0 0 0 0 1 0 1 1 1. If we perform transpose or find the transpose of the matrix, it will look like 0 0 1 0 1 1 0 0 1. After performing the transpose process, if we reverse each row of the transposed matrix, it will look like 1 0 0 1 1 0 1 0 0. That is the ultimate matrix if we perform the 90-degree rotation on the original matrix. So thus we can find the 90-degree rotation resultant matrix. But how can we find the transpose? See, in the original matrix and in the transpose matrix, the main diagonal remains same. Only the upper triangle element and the lower triangle elements are swapped. That means 0 becomes 0, this 0 comes to here, and 1 becomes here. This 0 will be at this position and 1 will be at this position. This is the logic. Now, if we see here, mat 01 comes to mat 10 and mat 02 comes to mat 20. Similarly, mat 12 comes to mat 21. That means you can see that the I, if we consider this the first variable as I and this as j, then I will be go through from 0 to n minus 1, and the j will be from I plus 1 to the n. This is the logic for the loop implementation. Now coming to the code implementation, we can see that n is the length of matrix. Now we have already seen that we will try to find the 90-degree rotation of the matrix 4 times. If mat equal to target in any turn, then we will return true. Otherwise, we will check for the next one, and after 4 times 90-degree rotation implementation, we will simply return false, false if we are not able to find mat equal to target. Now coming to the rotate function, as we discussed already, the I will go till 0 to n minus 1 and j will I plus 1 to n, and simply we will perform the swap operation to get the transpose of the matrix. And after finding the transpose of the matrix, current matrix, we will simply reverse each row of the current matrix. And finally, we will able to find the 90-degree rotated matrix of the current matrix. And similarly, we will check for every cases. And this is the ultimate code for the solution. Now run the code. Yeah, it's running. Now submit. Yes, so our code is running good. If you like the video, please do like, share and subscribe our channel and follow for more such content. Thank you.